Okay, so here are the notes for section 12.2, surface area of prisms and cylinders. The first part here is going to be kind of long, where I'm going through all the formulas and all the definitions and parts. So I'll try to make it as quick as I can, but there's a lot of important stuff in here. So we've already found areas of polygons. Now we're going to talk about lateral surface areas and total surface areas of prisms and cylinders. So first, what the heck is a prism? A prism is basically, kind of the way you can think of it as a three-dimensional polygon. More importantly, though, with the prism, what you have is a polyhedron with two parallel. That's the key there. The key word is parallel. Because when we get to pyramids and cones, they won't be parallel. So a polyhedron with two parallel congruent bases. And the lateral faces, they define here, are the sides, okay, which are basically everything but the bases. And then they have lateral edges, which are all parallel and congruent. And they intersect to form base edges. Now, the other definition that's really important for us is the altitude. Because the altitude is a perpendicular segment that joins the planes of the bases. The height is the altitude. The way to think of the height of a polyhedron, or a prism in this case, is how far apart are the two bases. How far apart are these two guys? How far apart are, really in this case, the planes that contain these two guys? So, or all these lengths here, like so lateral edge is a side edge, it's also the altitude. The bases are the top and bottom. Lateral face is just a side. Base edge is just an edge, which is basically a segment that forms around the sides, around the bases. Now the tricky part here is on the oblique prism, the one where it's not straight up and down. The lateral edge is this segment right here, but the actual altitude is this segment here. So for the right prism, it's the same. For the oblique prism, it's still always that perpendicular distance between the two bases. And in this case, the bases, for some reason, don't line up on top of each other, be the planes that are parallel to them. So again, lateral are the sides without the bases. Okay, that's the key. Faces that are not bases are called lateral faces. As far as lateral surface area is concerned, if you look at this prism they've got over here, it's a triangular prism. You know that it's triangular because that's, you name it by the base, and the two bases are the two parallel sides. The top and bottom are parallel. Now what happens is you could cut along a side here, like right here. Let's see where they cut it. Yeah, they cut it A and C. So I could cut just right along here. Oh, let's not use crayon. That's not a very good one to use. Let's use marker, pen. Yeah, and we'll just cut right down this seam. And when you do that and then cut along like right here, what happens is it opens up and you get the two bases and you get this big rectangle actually. And to find the area of that rectangle, it's all the three sides of the bases, A, B, and C, A, B, and C, added together and then multiplied by the height. So that's what the formula for lateral surface area is, the A plus B plus C times the height, which is the perimeter of the base times the height. That's the formula for lateral surface area. So the lateral surface area of a right prism is the perimeter of the base times the height. Okay. And then if you want total surface area, you just add on the two bases. So it's lateral surface area plus the two bases. Or the formula I always write out is perimeter of the base times the height plus the two bases. Okay. Now if this is a cylinder, which a cylinder is basically just a prism, but instead of being polygons at the top and bottom, it's a circle. Okay. What we can do is we can take the formula for perimeter and replace it with circumference, which is 2 pi RH. And then the area of the base is a circle, so lateral surface area instead of being perimeter times height is 2 pi RH. Or I guess you could say pi dH, but they tend to keep it in R because then once you go to total surface area and you add the two bases, the formula for area of a circle is pi r squared, so it's 2 pi r squared. Okay. So that first part's a little long, but that's all the formulas for this section. Okay. Lateral surface area, again, is just really cut that open. It's a big rectangle here. Perimeter of the base is A plus B plus C. Height is H. And then once you do total surface area, just add on the two triangles. And then for a cylinder, it's the same idea. The shape is still going to be this rectangle right here, okay, where this is the height, and this is the perimeter, which for a circle is circumference. All right, so let's look at some examples then. So, find the surface area of the rectangular prism. Now for this, we're going to do total surface area, and I'll explain why when we get to the problem in a second. So, do your best to figure out what the total surface area is and then come back. Okay, so now when we look at this problem, here's the issue. By definition, for a prism, the bases are the two parallel sides. Well, in the case of the rectangular prism, the bases are any two sides that are across from each other, because if I look at the front, let's say, even though most people would say, no, the bases are what it sits on. Well, give me a second. If I look at the front and the back, hey, those two guys are parallel to each other. And if I look at the top and the bottom, which people are prone to do, say, hey, that's the base. Well, look, this guy's parallel to this one. And then if you say, well, wait a second, aren't there sides in here and then back here? Yeah, you're right. There are sides there as well. And guess what? Those sides also parallel. So for the rectangular prism, if you're going to use the formula for total surface area being surface area equals 2b plus perimeter times height, you have a bunch of different sides you could choose as your bases, and that's the key with the rectangular prism. So I'm going to use the one in red as the base. Okay, so the base equals red rectangles. So for the area of the base, it's a rectangle, so it's base times height. We'll call this guy the base. We'll call that the height. So it's 72 squared centimeters for the base of the rectangle. Now, one of the things to remember is the height here in this formula is not the height in this formula. This is the area of a rectangle. This is the height. This here is the distance between the bases. And that always throws people off, but the height we're talking about, I'll get to in a moment, is not that height. Well, I've got the area of the base, okay, 72, that's the area of that rectangle here. Now what I need is the perimeter of the base. Well, the perimeter is going to be 6 plus 12 plus 6 plus 12. So 18 plus 18 is 36 centimeters. Now, like I said, the last thing I need then is the height. And the height for the prism, which is what the H stands for in the formula, is the distance between the red base and the red base, the two rectangles. Well, how far apart are those? Right here, 6 centimeters. Okay. So it's that height. So surface area is 2 times the area of the bases plus the perimeter of the base times the height. And if we're really feeling lazy, we can just go ahead and grab our calculator and plug it in. If it starts up. There we go. So 2 times 72 plus 36 times 6. 360. So 360 squared centimeters. There we go. All right. First example down. All right, next example, triangular prism. Now this one, it's easier and harder. It's got a couple of extra little weird twists to it. So here we go. And it does say find surface area, so we'll do the total surface area. All right, so the first thing that makes this one easier, one is we are still going to use the perimeter equals 2 times the area of the base plus the perimeter of the base times the height. We're going to use total surface area. Sorry, not perimeter, surface area. Okay. We'll do the total surface area, so TSA. Okay. Now, what makes this one a little trickier, or makes it easier, is the base is more obvious this time. The base has to be the triangles. These are the only two sides that are parallel. So the bases are that. And then the distance between the bases, that's easy too, because that's the height of this prism, is the 10. Okay. So versus the last problems, or the last problem where I had all the different sides to be the bases, this one it's just one, just the triangle. Okay. Now, what makes this difficult though is when we get to the perimeter of the base, and we'll get to that in a second. So the area of the base is a triangle. So it's 1/2 base times height. Well, this is the length of the base. This is the height of the triangle, because that's all we're working with. So 1/2, 12 times 8. So 6 times 8 is 48. We have units here. Nope, 48 units squared. So there we go. 48 is the area of a base. The height we've already established is 10. So what we need now is we need the perimeter. That's where we run into a problem, because I'm missing the two sides for the length of this prism. Now, the one thing we have to make an assumption on here, and I would be clear on this in a test or quiz situation, is that this triangle is actually isosceles. They didn't tell us that, but we have to make that assumption. And so the reason is, when I cut this in half, or when I draw the altitude in there for the triangle, the height for it, that cuts this in half here. Meaning this triangle is actually 8 for the height. Instead of being 12 all the way across here, it's half of that, it's 6. Which then means to find the side length here, that's really easy because this is a 6, this is an 8. We could do the Pythagorean theorem, but we don't need to. It's a 6, 8, 10, because it's really a 3, 4, 5. And so now we have that. We will do the perimeter, which is 12 plus 10 plus 10. Okay. So perimeter is 32. Area of the base is 48. Height is 10. Now ready to finish this problem up. So total surface area is 2 times 48 plus 32 times 10. That's going to be 96 plus 320 equals 416 units squared. Okay, last one. Lateral surface area and total surface area of the cylinder. Okay, so this is the one we'll do lateral and total. All right, so the lateral surface area, which I call LSA, is just perimeter of the base times the height, which in this case is circumference times height, which in this case is 2 pi r h. Okay. Well, the radius is easy, and the height is easy. So there's not much to do on this one. 2 pi, radius is 12, height is 20. So this ends up being then 480. Is that right? I don't know. I'm trying to throw this in my calculator. I'm trying to do this in my head. I feel like I did something wrong. 2 times 20 times 12. Nope, 480. So it's 480 pi feet squared. But they said they wanted this to be nearest tenth, so now we'll multiply it by pi. And that gives us 1507.9. Well, actually, it's 15.8 or 1508 square feet. Okay. Now, for total surface area, then, it's the lateral surface area plus the two bases. Okay. We already know the lateral surface area, 480 square feet, or 480 pi. The bases are just 2 pi r squared. Okay. So 480 pi plus 2 pi times 12 squared. Well, that ends up being then for us 288 pi, which 480 plus 288, I don't need to do in my head. That is 768 pi, which feet squared, which then as a decimal approximation, (2412.7). Ugh, not 21.4. Oh, barely snuck that in there into the frame. All right, and that's it.